first of all, does anybody remember what a secant line is? It's been a while since we looked at that term. In terms of the graph is the best way. What does that word secant mean? What's another word for secant? Does anybody remember? Average rate of change. I will tell you this. A secant line requires 2 points. A tangent only requires 1. Okay. We're going to jump to the first example. We're going to look at the graph to help you understand this. What is the equation of the secant line of this graph on the interval 3, 7? So, like I said, with secant line, you need 2 points. So notice we have two x values. We have 3 and we have 7. Now, really what this question is asking goes back to what she said. It's the same thing as finding the average rate of change first, but we need an equation for that line. Okay? Does anybody remember the equation for a line from Algebra 1?
Is it like what?
Y equals, there you go. So ultimately, our answer is going to be the form y equals mx plus b. What you're doing, we're going to take a look at the graph. Here is the graph of our function. It's a parabola. Now notice we have, I have both points labeled here, 3, 2, and 7, 10 on the graph. Now the secant line is just the line that connects these 2 points. And you don't have to draw any of this. But it looks like that. So what we're actually trying to find is an equation of that line. Okay? And again, every line we can write it in the form y equals mx plus b. In order to find the equation for a line, the m represents the what? Does anybody remember? The slope, and the b represents the y-intercept. Exactly. Now, if you're given an equation, how do you figure out the y values? You just plug the x value in, right? So for this equation, the way we'd figure out 2 is we'd plug in 3 into the equation. The way we'd figure out the 10 for this point is just plug in 7. So that's what we're going to do. First of all, just go ahead and label the interval they give you. Again, it's got to be 2 different x values because in order for the secant line to exist, there has to be 2 points. So my x1, I'm going to label 3. My x2 is 7. It's important to note the 2 x values they give you are not a point, right? They're 2 different x values. To figure the point out, you have to plug these x values into the equation. All right, so that's step 1, label the interval. Step 2, determine y1 and y2. Again, you do that by plugging the corresponding x values in. So I plugged in x1 first. I get 1/2 times 0, which is 0 plus 2. So my y1 value is 2. Now you might be asking, why are we figuring out y1 and y2? Well, what's the equation for slope? How do you figure out? There you go. Good. y2 minus y1 over x2 minus x1. We can't figure out the slope of that line until we figure out y1 and y2. Okay, so to figure out the second y value, you will plug in 7, because that's x2. You get 1/2 times 4 squared, so it's 1/2 times 16 plus 2. You guys can just write the y value for this, so you don't have to show all your work. I think you understand what's going on. So 1/2 of 16 is 8, and 8 plus 2 is 10. So y2 equals 10. Okay, and you already alluded to what the equation for a line was. It's y2 minus y1 over x2 minus x1. So we'll take all of that information, the y2s and the y1s, the x2s and the x1, and we'll figure out what the slope is. And it's important to always go back to the graph. So basically, to find the slope, it's just change in y over change in x, right? Which is exactly what y2 minus y1 over x2 minus x1 gives you. You can look at the graph and actually see what the slope is. What's the change in y? It looks like 8, right? So it's going to be 8 over 5, which is the change in x. No, so 4, sorry. 8 over 4, so you can see the slope's going to be 2. I like to keep going back and looking at the graph just to refresh my memory on why I'm doing what I'm doing. So there's the formula for slope. For step 3, you'll figure the slope out. And again, this one's going to be 2. I understand that sometimes you want to always keep slope as a fraction just because it is rise over run. So if you want to write it as 2 over 1, that's fine. But in the equation, you'll just have a 2 there. Okay, now we need to find what? The y-intercept. So what you're going to do is write out your line equation of formula, and then you're going to plug in your first point that you found, x1, y1. You could actually do x2, y2. I usually just go with the first one though. And then you're also going to plug in the slope that you just found. Okay, so we're plugging in the first x value followed by the first y value plus the slope and solving for b. So you're going to get 2 equals 6 plus b. What do you think b is going to be? Okay, so 2 equals 6 plus b. I can go back to this in a second if you need it. Subtract 6 from both sides. B equals -4. So step 6 is solve for b once you solve for slope. Okay, so how do you write the equations? You may know if you know the slope and you know the y-intercept. What do you leave the same? In the equation, you're going to leave x and y the same, right? You're just plugging in the slope and the y-intercept. So instead of y equals mx plus b, you just plug in m and b, and that's your equation. Alright, so is this what you guys got when you plug it in? You plug in the slope. You just plug in the slope and you just plug in the y-intercept. Why is that? Because in order to have an equation, you have to have an x and a y. The way the equation works is you plug in an x and you figure out the equation for the line. Now I really want to show you what this means in terms of the graph. That means that the equation for this line is y equals 2x minus 4. Down here they have it in a different form. This is in standard form. But notice if you added 2x to both sides, you get y equals 2x minus 4. That's all we're doing. Before we just found the slope of the secant line, which is the average rate of change. But every line has an actual equation. Okay, and in the future we're going to be doing the same for tangent and normal line. We're going to hold off on example 2 until tomorrow. Just give you the worksheet.